Hello, everyone. My name is Jamani Balderamos. I'm a coastal engineer. I've been working with Fragments of Hope for the past 2 years. And today I'll be sharing our work entitled Drones Can Quantify the Full Extent of Large-Scale Shallow Reef Restoration Success. Before I start, I'd like to acknowledge the work's co-authors, Ms. Lisa Karn, who is the Executive Director of Fragments of Hope, Dr. Steve Schill, who works for the Nature Conservancy in the Insular Caribbean and has been providing advice on the use of drones, and Ms. Emily Peters, who has also worked with Fragments of Hope since 2019. Fragments of Hope works in the country of Belize, and if I can draw your attention to the map in the lower right-hand side, you'll see more or less where we work in the Central American region. And we have sites distributed throughout the country of Belize. The northern two most sites, which you can see here in the map in the upper right-hand side, were created in response to the stony coral tissue loss disease. We have several sites located on the largest of our 3 atolls, the Turneffe Atoll. However, the bulk of our work is focused in the southern regions of Belize. Now, if I can draw your attention to the map on the left-hand side, I'd like to highlight the 3 sites that we'll be covering in today's presentation. The first is Laughing Bird Key, which is located within the Laughing Bird Key National Park. It's a protected site with restoration started in 2006. The second site is Moho Key, which is an unprotected site located to the northeast of the Laughing Bird Key National Park. And the third site, which isn't displayed on this map, but is found to the west of the Laughing Bird Key National Park, is the Loggerhead Key, where we have found several natural stands of all the aquaporid species of corals. Fragments of Hope, as I mentioned before, has been working in Belize since 2006. And since then, we've outplanted 159,071 coral fragments. If you look to the pictures on the right-hand side, you can see that initially the coral fragments are grown in some type of nursery. In this case, it's a tabletop nursery. And when the fragments are still very small and unplanted, it's very easy for a diver to measure them to quantify their dimensions. However, after the fragments are outplanted and the colonies begin to establish themselves, it becomes a little more labor intensive. And how we've managed to quantify the aerial growth and the change over time is by creating diver-based photomosaics. In order to do this, we've created plots which range between 50 square meters to 200 square meters. And a person will swim a lawnmower pattern in the plot with a large camera assembly. These photographs are then put into a structure from motion algorithm, which produces a orthophoto mosaic. Now, although this is a great technique for measuring the area, as you can see in this graph shown on the screen, it definitely shows the live coverage change over time, and it can show you that the coverage of live coral within these plots have been increasing. It does not capture the full scale of the coral restoration. We can also use the data from the diver-based photomosaics to measure the aquaporid coverage of the total area of live coral within the plots. But as I mentioned before, if you look to the final photograph on the far right-hand side, you'll notice that Lisa Karn is about to swim a photomosaic in a 180-meter plot. But as you can see in this photograph, the coral has well outgrown the plot, so we're not capturing the full scale of the coral restoration. So in order to capture the full scale, we decided to turn to drones. With the large-scale success at our restoration sites, we needed this method to quantify the full coral growth. The drones are able to provide a very high-resolution bird's-eye view of the restoration sites and are able to capture the full extent of shallow coral cover. Our method involves 3 parts. So the initial part is a fieldwork campaign in which we use a drone to collect photographs. The drone is flown at 200 feet and the photographs are collected with a front and side overlap of 80%. The second step is applying a structure from motion algorithm. Now, this algorithm is done in our software of choice, which is Pix4D Cloud, because this processing can often be very computationally demanding. And the result of this processing is an orthophoto mosaic. The orthophoto mosaics are then exported in the WGS84 coordinate system in a projection of UTM zone 16N. And the final step is the GIS annotation. The orthophoto mosaics are loaded into a GIS program. For this, we've been using QGIS as it's a free and open source program. And polygons are created and the individual aquaporid species are then digitized. This can be quite consuming and somewhat labor intensive. It is subject to great subjectivity, as the persons doing the annotation may misinterpret the orthophoto mosaics and either underestimate or overestimate the size of the coral colonies. Laughing Bird Key, which is our oldest and most successful restoration site. In 2019, we started using the drones, and we were able to quantify a total of 2,240 square meters of aquaporids. The following year, we repeated the same procedures, and we were able to quantify 2,397 square meters, representing a 7% change in aquaporid cover. Now, in between 2020 and 2021, Belize was struck by a hurricane. The hurricane damage resulted in a spread of smaller fragments of the 3 aquaporid species. And in 2021, when we did our drone flights and we measured the coral, we found that the percent growth between 2020 and 2021 had increased to 14%. The second site, as I mentioned before, is an unprotected restoration site at Moho Key. And since 2015, we've outplanted 22,630 fragments. Now, as you can see in the orthophoto mosaic on the right, while the drone is able to capture at the large scale of coral restoration, doesn't do a good job of capturing the density. And what I can say here is that although we've outplanted several fragments of the Aquapora palmata, the drone does not pick them up. So that's one of the caveats of using the drone. One of our research questions, one of the things we're interested in answering is how big these corals need to be in order for the drone to pick them up. And as I mentioned before, although the drone does a good job of capturing the scale of the restoration site, it is unable to capture the density of the coral. And as you can see in this picture on the lower right-hand side, this is a part of the restoration at Moho Key. And although it's quite impressive and striking to look at in the photograph, the drone does not show or does not fully capture this level of impressiveness. The final site is Loggerhead Key. And as I mentioned before, this is a natural site. No restoration is taking place at this location. And as you can see in the table on the lower right-hand side, the numbers of coral have increased over 3 years of monitoring. So the drones allowed us to locate 2 coral colonies that we were unaware of previously. One is the Aquapora palmata and the other is Aquapora prolifera.
We've also been able to use the drones for monitoring bleaching and storm impacts. Well, the drones only work in very shallow areas, that is anywhere between 0 to 10 meters. They work best in restricted conditions. There are costs associated to the drone use. For example, the cost of a casualty, each drone is approximately $1,500. Multiple batteries are required, and that boosts up your cost a little bit, as well as the structure for motion software for processing the overlapping images into the orthophoto mosaics and digital elevation models. There's quite a bit of subjectivity in classification in digitizing the stands of aquaporids. And finally, our next steps, we'd like to equate the shallow water restoration with shoreline protection, which is why we have a coastal engineer working with us. And finally, we want to continue to quantify yearly changes and improve our methods, possibly using some machine learning. So a huge thank you from the team in Belize. I'd like to close by showcasing a list of our partners and sponsors. And if you're interested in finding out more about Fragments of Hope, please feel free to contact Lisa Karn